Okay, welcome back again to our topic, this mathematics or mathematics series. Our topic today is about coordinate geometry. Okay, coordinate geometry part 5. Okay, students, directly we go to the question. But before we go to the question, we are going to discuss first about the collinear points. Collinear points. So what is collinear points? Collinear points are the points that lie on the same line. If two or more than 2 points lie on a line close to or far from each other, then they are said to be collinear. Okay, based on Euclidean geometry. Okay, so collinear points are the points that lie on the same line. Okay, next. Okay, this is the XY coordinates, okay, or graphing paper. In geometry, two or more points are said to be collinear if they lie on the same line. That means something being in a row or in a line. Okay, so what is the concept of the collinear points? Just use slope formula. So how about using slope formula? Three or more points are said to be collinear if the slope of any two pairs of points is the same. Once again, three or more points are said to be collinear if the slope of any two pairs of points is the same. Okay, look at the diagram. Okay, there is a line. Okay, please give attention to the black line on the graphing paper on your screen. Okay, let's say this is the coordinate A. The coordinate A is -5, 2. And then coordinate B is 0, -2. Okay, and the coordinate C, this is the point C. The coordinate is 5, -4. Students, 3 points A, B, and C lie on a same line, right? So 3 points A, B, C, they lie on the same line. So we can take the conclusion for the A, B, C points, they are collinear points. Based on the graph, the points A, B, and C are collinear. Is it clear, everyone? That's collinear point, right? Okay. Now we go to the question. Okay, to make sure all materials about the collinear points clear. Now we go to the question. Okay, this is the exercise 1. Okay, the question is the coordinates of 4 points A 0, 9, B k plus 1, k plus 4, point C 2k, k plus 3, and point D 2k plus 2, k plus 6. Find the value of K A. The points A, B, and C are collinear. And question B, AB is parallel to CD. Okay, everyone? This question is very easy actually. Okay, when we go to the question A, okay, the question A that points A, B, and C are collinear. Okay, now we're going to list all the points below. This is the point A. Okay, point A is 0, 9, and point B is k plus 1, k plus 4. Okay. Point C is 2k, k plus 3. Here, right? And point D, sorry, okay. And point D is 2k plus 2, 2k plus 2, k plus 6. Okay, k plus 6. Is it right? Okay. So point A 0, 9, B k plus 1, k plus 4, point C 2k, k plus 3, and point D is 2k plus 2, k plus 6. Okay. Now we go to the question that the points A, B, and C are collinear. Okay, students. point A, B, and C collinear. Okay, so A and B collinear and B C collinear. Okay, so that's the concept of the collinear. Okay, so the first method that you are going to solve this question. Okay, the closest contact. How to find points A, B, C or collinear is by using the gradient. Okay, our method is gradient. Okay. Gradient. What is gradient? Gradient is the steepness of the line, right? The gradient is the steepness. Okay. Okay. Gradient is the steepness of the line. Okay. Okay, students. Let's say here is A. This one is A. And here is B. Okay. And here is C. Right? Now we're going to use the gradient approachment. So what is the gradient? This is the gradient, right? Okay, I want to give the approximate gradient to solve this question. Okay. Okay, good. Okay. And here B. Good. Right? Okay, next. Here this one is the steepness of BC, right? Right? This one. Right. Okay, now we're going to find any information from this line because A, B, C are collinear. Okay. Okay, now. Okay, students, for connecting AB, the line that connects AB or connecting AB here, okay, this is the connecting line of AB. Here's the gradient, okay. Let's say this one, the gradient is M1. And the connecting line for BC here, this one is BC, for the connecting line for BC, let's say this one is M2, the second gradient. Okay, so the conclusion is M1 equal M2. Okay, because M1 equal M2, M1 equal M2, so the conclusion that A, B, C are collinears. Okay, students, A, B, C are collinears. Okay, point A, point B, and point C are collinears. Is it clear, right? Okay. Okay, our method to solve this question by using the gradient. Okay. Now we are going to find M1. Okay, M1. M1 is delta Y over delta X for AB, right? Okay, and M2, yeah, M2 equal delta Y over delta X for BC. Okay, BC. Okay. Okay, now we're going to point A and B. Okay, we're going to determine first. This one is x1, y1, and this one x2, y2. Okay. Okay, next for M2, here M2, AB. Okay, for point AB. So y2 minus y1, k plus 4. All right, here. Minus 9, right? Minus 9. Okay, and then delta x. x2 minus x1. So k plus 1, minus 0. Okay, so M2 equal here k minus 5 over k plus 1. Okay, now we have the first gradient. Here is 1, right? This is the first, our first gradient. Our first gradient is 1. Sorry, so one is M1. Sorry, okay, this is M1. Sorry. Okay, sorry for the symbol here. This is M1. Sorry, yeah, M1. Here is M1. Sorry, yeah. Here is M1, okay? Okay, M1. Okay, clear, right? Now we're going to M2. M2 is the gradient connecting BC. Okay. Okay, now we go to M2. M2 equal delta y over delta x. Okay, now M2 is the line connecting BC, right? So delta y over delta x for point BC. Okay, BC. This is BC. Okay, now we go to y2 minus y1. Okay, BC y2 minus y1 here. Right? Okay, so M2 equal y2 minus y1. So k plus 3 minus k plus 4. Good. And then x2 minus x1, right? x2 minus x1 over here. Right? So you have to insert here 2k minus k plus 1. Yeah, right? Next, so we can simplify this equation. K plus 3 minus k minus 4, it will be minus 1, right? Over 2k minus k plus 1, so k minus 1. Is it correct, everyone? Is it correct? So this is M2, right? Okay, good. Okay, now we got M1, k minus 5 over k plus 1, and M2 is minus 1 over k minus 1. Okay, because 3 points are collinear, okay, 3 points collinear. Now we can take the conclusion or to resume here. Okay, A, B, and C are collinear. Okay. Okay. So means M1 equal M2. M1 equal M2. Okay. M1 is k minus 5 over k plus 1, right? And M2 is minus 1 over k minus 1, right? So what should we do? What should we do? Right. We have to do what? Cross multiply, right? Cross multiply. Here minus here. Oh, sorry. Diagonal. The first diagonal and the second diagonal, right? Okay. We can simplify the equation by doing the cross multiply. K minus 5 close the bracket, open the bracket, k minus 1 close the bracket, equal minus 1 times k plus 1, right? Next, this is the, what is it? Quadratic equation, right? This is the quadratic equation here, right? So remember this one, right? Quadratic equation, right? So we can continue. So the answer is k squared minus k minus 5k plus 5 equal here minus k, and here is minus 1. Is it? Next, so k squared minus 6k plus 5 equal minus k minus 1. And then all these items will be moved to the left side. So k squared minus 6k plus 5, right? Positive k plus 1 equals 0. Okay, we can simplify k squared minus 5k, and then here 5 plus 1, right? Positive 6 equals 0. Okay, now factorize. Is it factorized? Okay, this one, C is positive, right? C is positive. Okay, so it will be negative, negative. Factor of k squared is k. Factor of 6, but we have to sum up to be minus 5. It will be minus 2 and minus 3 equals 0. Right. So the answer is k minus 3 equals 0 or k equals 2, or k minus 3 equals 0 or k equals 3. Okay, this is the final answer for the points A, B, C are collinear. Okay, so K equal to and K equal. Okay, students, we go to the question B. AB is parallel to CD. Okay, AB is parallel to CD. Okay, what is the meaning of the two lines are parallel? Okay, let's say this one is the first line, okay, for AB, and this is the second line for CD. Okay, okay, one this the line, both are parallel. Okay, now the information of the parallel. Okay, let's say the black line is AB. Okay, it is AB. Okay. And the second line for the red line is CD. Okay. Both are parallel. Yeah, because both are parallel means the gradient of AB will be equal to the gradient of CD. Right? Okay, this is the concept of parallel, right? Okay, once again, parallel. AB, okay, AB is parallel to CD means M1 equal M2. So this is the concept. This is the concept of the parallel line. So M1 equal M2. Okay, students, students, we already got M1, right? We already got M1. This is the M1, right? Okay, M1 for AB. Okay, okay. Line AB will be parallel to line CD. Now our job is to find the gradient of CD. Okay, yeah, this is our job to find the gradient of CD. C and D. So this one here, C, right? Okay. So this is the gradient, right? This is the gradient. Okay. This is the gradient. Let's say we call this M2. M2. So equal M2 is delta Y over delta X. Okay? Equal. So what is the formula of delta Y? Or Y2 minus Y1 over X2 minus X1, right? Now we are going to check this one, the Y2 and Y1. This is the Y2, right? And this one is Y1. This Y2, K plus 6, and Y1 is K plus 3. This one, right? Okay. Okay, next. Now going to insert here. Y2 is K plus 6 minus Y1 is K plus 3. Okay, don't forget to put the bracket to avoid any mistake, right? And then for X2 here, this is X2 here, and this one is X1. So here is X2, and this one is X1, right? Okay, clear? So X2 is 2K plus 2, 2K plus 2, and then minus X1 is 2K. Okay, good. Okay, did you find any mistake here? No? No, no mistake, right? Okay, next. Okay, next we can simplify. K plus 6 minus K plus 3. Okay, I think we got 3, right? Because K minus K is cancelled, 6 minus 3 is 3, right? And then for the denominator, 2K plus 2 minus 2K, I think we got 2. Huh, that's very simple. We got the fraction, right? So M2 is 3 over 2. So M2 is 3 over 2. Okay, clear one? Okay. Now we have M2 here. Good. Okay, students, what is the concept parallel? Okay, the concept of parallel. Okay, students, for the parallel, okay, parallel. Two lines are parallel means M1 equal M2. So you just insert M1 here. Okay, M1, where is M1? Here, so this is M1, right? M1. So M1 insert with K minus 5 over K plus 1. And for M2 is 3 over 2. This one, right? Over 2. Okay, don't forget to put the bracket here to avoid any mistake. So by doing the cross multiply here, the cross multiply the first diagonal and the second diagonal, right? Okay, good. Now we go to the solution, right? Go to the solution. By doing the cross multiply, we got here 2, open the bracket, k minus 5 equal 3, open the bracket, k plus 1. Okay? So 2k, right? 2 times minus 5 is minus 10 equal 3 times k is 3k, and then 3 times 1 is 3. Okay, so what is the solution? Okay, students, 3k will go to the left side. Okay, so it will be 2k minus 3k. Okay, and then minus 10 is 1, right? Minus 10 here is 1. We'll go to the right side here. Okay, we'll go to the right side. So we'll find here 3 plus 10, right? This is minus 10. When you go to the right side and then it passes the equal symbol, it means the sign will be changed, right? Next, 2k minus 3k is minus k. 3 plus 10 is 13. So the value of k is minus 13. Okay, you got the K for question B. Okay, next we go to the exercise 2. Exercise 2. The vertices of triangle ABC are A 0, 1, B minus 1, minus 2, and C 2, K. Find the value of K if angle ABC 90 degrees. Oh, good. Okay, we go to the triangle. Okay, we're going to draw the triangle. Okay, draw the triangle. Okay, and then 1. Okay, okay. Sorry for my drawing is not perfect. Okay, go. Okay. Start answering this question, right? 1. Okay, the information we have here, okay, the information is angle ABC 90 degrees. So this one is B. Yeah. Why here B? Angle ABC. Okay, the middle letter is B. So here is 90 degrees. B. Okay. The clear one? B. And then let's say this one is A. Okay. So automatically here is C. Okay, point B is minus 1, minus 2. Okay. And then A is 0, 1. And C is 2, 8. Okay, good. Find the value if angle ABC is 90 degrees. Okay. So what is the information that we are going to have from this diagram? Okay, good. The information. Okay, because angle ABC is 90 degrees, okay, means line AB is perpendicular to BC. Once again, good. Okay, line AB, sorry, line AB here is perpendicular to C. Here, perpendicular, right? Okay. So what's the meaning of perpendicular? Perpendicular means the gradient of AB, let's say M1, and the gradient of BC, let's say M2. We have the concept of the perpendicular line each other is M1 times M2 equal minus 1. This is the concept, right? M1 times M2 equal minus 1. This is the perpendicular. Okay, so now we're going to find M1. M1 for the AB, right? Okay. M1 is y2 minus y1 over x2 minus x1. Okay. This one is x1, y1, and here is x2, y2, right? Okay, go. So M1 is y2 is minus 2 minus y1 is 1, and then x2 here minus 1, right? And x1 is 0. Okay, so we got M1 is minus 3 over minus 1, means we got M1 is 3. Okay, now we're going to M2, gradient 2, the line that connecting BC. Okay, line BC. Okay, now we're going to BC. We're going to list here for B is minus 1 comma minus 2, and C is 2 comma K. Okay. Okay, students. Yeah, this one is x1, y1, here x2, y2. Go to the gradient. M2 equals delta y over delta x. So equal y2 minus y1. So k minus 2. And delta x, x2 minus x1. 2 minus 1. So we'll find for M2 is k plus 2 over 3. So the perpendicular line, okay, perpendicular M1 and M2 perpendicular, right? M1 and M2 perpendicular, right? So what's the meaning? M1 times M2 equal minus 1. Okay, M1 is 3 here, right? 3. M2 is this one, right? K plus 2 over 3 equal minus 1, right? Clear? So we can cancel this one. Cancel, right? So K plus 2 equal minus 1. So K is minus 3. Is it clear, everyone? So M1 and M2 perpendicular. Okay, we go to the exercise 3. Okay, exercise 3. What's the question? Oh, the coordinates of 3 points are A1, 3, B 5, 1, and C K, minus 1. Find the coordinates of the midpoint M of AB. B. If MC is perpendicular to AB, find the value of K. C. Calculate the length of MC. That's very easy question as well. Okay? Okay, next. We're going to answer this one. Okay? Point A. Okay, point A here. Point A is 1, 3. Point B is 5, 1, and point C is P, minus 1, right? The coordinates of the midpoint M of AB. Okay, this is the midpoint. Okay, let's say this one is AB. Okay, this is AB. Here is A, here, and this one is B. A is 1, 3, and B is 5, 1. The midpoint means the point lies on the middle, sharp, okay, of point A and B. So this is the midpoint of AB. Let's say this one is M. The symbol is M, right? Just put here M. Okay. M is the midpoint of AB. So means, okay, this is the formula of the midpoint. XA plus XB over 2 comma, YA plus YB over 2. Okay, clear? So the midpoint of AB is, okay, this one, this is XA, YA, XB, YB, right? So 1 plus 5, okay, 1 plus 5 over 2, comma, 3 plus 1, 3 plus 1 over 2, okay? So the midpoint is 3, comma, 2. Clear? This is the midpoint of AB, okay? Okay, remember the formula for the midpoint. This is the formula of the midpoint. This one. Okay, I want to put this one here. Okay, I want to. Okay. Here is the formula of the midpoint. Okay. Okay, clear one? This is the midpoint formula. Now we go to question B. So what is the question B? MC is perpendicular to AB. Oh, perpendicular. Okay, this is the question B. Yeah. Okay. AB is here. This one. Okay. Perpendicular to MC. Here, this one. Okay, good. Very easy, right? Okay. Then this one is C. Okay. And this one is N, okay, and here is A, and here is B. Right. Perpendicular means two lines form a right angle here, 90 degrees, right? Perpendicular, right? So the first is we are going to find the gradient of AB, right? And the second, we are going to find the gradient of MC. Okay, MC. Clear? So, because both are perpendicular, perpendicular line. Perpendicular lines means gradient AB times the gradient of MC, okay, equal minus 1. Okay, this is the concept, right? This is the concept. For perpendicular lines, okay, for perpendicular lines, this is the concept. Okay, this is the concept. Okay, so I want to box this one. This is the concept or the formula for the perpendicular line. Okay, students, the first step is you're going to find MAB. Okay, MAB. Okay, now we're going to list again the coordinates. A is 1, 3, and then B is 5, 1, right? Okay, so MAB. Okay, delta Y over delta X, right? Y2 minus Y1 over X2 minus X1. Okay, go. Y2 minus Y1 here. Okay. Equal 1 minus 3 over next X2 minus X1, right? So we'll find 5 minus 1. Is it correct?
Yes, sir.
Okay, go. So the answer is minus 2 over 4. And finally, we got minus a half, right? This is the gradient AB. Clear? Okay. Okay, students. Now we go to the second step. Okay. Okay, the second step. The second step is to find the gradient MC. Okay. The gradient MC. Okay. Okay, we're going to list again the coordinates of M. M is 3, 2, right? And C the coordinate of C. C is k comma minus 1. Okay, right? Okay, so then now we go to the gradient MMC. The gradient MC. The gradient MC equal delta y over delta x. Okay, equal here. Y2 minus Y1 here. Right? Right? So, minus 1 minus 2 over, and then x2 minus x1 for this one. Okay, good. Right? So, k minus 3. You can simplify this one. Minus 3 over k minus 3 in the bracket. Okay? Next, we go to the perpendicular lines. The perpendicular lines is MAB times MMC equal minus 1, right? Equal minus 1. Now, you're going to insert the number. The gradient AB is minus a half. The gradient of MC is minus 3 over k minus 3 here, right? Equal minus 1. Equal minus 1, right? Okay, so what about this one? How to simplify this one? Okay, that's very easy, right? Okay, go. Minus times minus, so it will be positive, right? Okay, so 3 over 2 times k minus 3, right? Equal minus 1. And now we're going to do the cross multiply, right? Cross multiply here, this one and this one, right? Now we're going to continue again this question. We're going to simplify. Okay, the simplification is minus 1 times 2k minus 3 equal 3, right? And then minus 2k plus 6, right? Minus 2k, and then minus 1 times 2 times minus 3 plus 6 equal 3. So minus 2k, sorry, by using the algebra, k is 3 over 2. Okay, so the value of k is 3 over 2. Is it clear? Okay, so now we go to the question C. Okay, the question C here. Oh, no space available here. Are you going to copy?
Yes, sir.
Okay, good. Okay, we're going to continue the question C. Calculate the length of MC. Okay. From the question A and B, we got extra information. Okay. For M coordinates. M coordinate is 3, 2, right? 3, 2. And then coordinate C is k, minus 1. But we got k already, right? So C is 3 over 2, minus 1. Is that or what? Because we got k is 3 over 2, right? Okay, now we're going to calculate the length of MC. Length of MC or distance or segment are equal. So this one is the formula. D. Yeah, this is the formula. So distance of MC equal root of, okay, x2 minus x1 square plus y2 minus y1 square. Okay. Okay. Now we're going to identify first. This one is x1. So this one is y1. This one is x2, and this one is y2. Now we're going to insert the number here. So the distance is root, okay, open the bracket, x2, 3 over 2 minus x1 is 3 in the bracket square plus y2 minus 1 minus y1 is 2, right? There one. Y2 is minus 1. Y1 is 2, right? In the bracket square, okay, clear. But in square root. Okay, everyone? Okay, continue. We're going to continue. So D equal root of 3 over 2 minus 3. Yeah, 3 over 2 minus 3 over 2, right? Minus 3 over 2 squared plus minus 1 minus 2 minus 3 minus 3 squared. Isn't it? But in square root. Next, so distance MC equal root of 9 over 4 plus 9. Is it? So equal root of, okay, simplify the denominator by doing the LCM here. 4, here is 9, right? Plus 36. Root. So distance of MC or segment, yeah, root of 45 over 4. So what is the root of 45? 9 times 5, right? So 3 root of 5 over root of 4 is 2. So distance MC equal 3 over 2 root of 5. Finish. You can use your calculator, right? How many root of 5 and then times by 3 over 2. Okay? You can use the decimal number here. But the formula is like this. Okay? So the length of MC is 3 over 2 root of 5 units. Is it clear, everyone?